friends, welcome back to another session on operating systems. We are into our second module where we are looking at process management. Process is an instance of a computer program that is being executed. The process, when we say it's a complete program under execution, but we can look into a smaller part of a process, and that is what we call a thread. A thread is the smallest unit of execution within a process, so we can convert or we can divide a process into multiple threads, so that these threads we can work independently on different processors if available, or we can make sure that these are run as if they are different processes. But yes, there is difference, and the difference is as far as a memory space is concerned. So each process will have a separate memory space for that, whereas the threads share the memory space of the process. So process will have a memory space, and all the threads under that process will share the same memory space. For communicating among processes, we require IPC, inter-process communications, which are very slow, but threads within a process can communicate very easily via shared memory, because all the threads within a process share the same memory space. Therefore, a simple shared memory concept can be applied here, and it becomes easy and fast also. Creation, yes, it is heavy for the process, because whenever a process is being created, first we need to look at what is the size of the memory required, what all the components of the memory required, how much memory is required for the code, how much memory is required for the data, how much memory is required for the stack, how much memory is required for the heap, and all that it has to find out, and then accommodate all the memory, reserve the memory for that, and then load the code from the secondary memory down to the primary memory at the allocated place and all that. So it is a heavy duty activity, whereas a thread is a lightweight. When we are creating a thread, we are just not copying anything from the secondary memory, because the whole process is already on the main memory. Only a light changes are required. We'll see exactly what is the difference between the process and thread when it comes to the resources required and all that. When it comes to the crash, then one crash does not affect the other process. So if one process is crashed, it doesn't make any difference to other processes, but these threads are under one process, and if one thread fails, definitely the whole process is going to get affected. So that's other difference. So we need to be very careful when it is thread version, because if any thread fails, then the whole process also will fail. So pictorially it gives a better understanding between the process and the thread. The left side is the process, so it contains one thread. That means the whole process is a single, whole code is a single unit. So it has got a place for the code, it has got a place for the data, it has got a place for different files used. Then it has got registers, contents of the registers, contents of the stack. This whole thing, one set of code, data, files, registers, stack, all are available for a process. But if we use the same process in terms of threads, then there are multiple threads. Then for each thread a separate stack is there, for each thread a separate memory is allocated to have its own register contents. So as we discussed in the previous session, then when the CPU is allotted from one process to another process, then the whole environment is saved. This saving of the environment is done in the memory, and when it comes to a process, we have one set of memory for storing register contents, one set of memory for the stack, whereas when we are talking about multiple threads in a process, then there is one code, there is one data, there is one file. The memory allocated for the code is only one. The same memory allocated for the code is used by all the threads, so they just use the same code. The data is commonly used by all the threads, so that is what we call shared memory. And the files it has opened and all the operations worked with the files is commonly used by all the threads. So that's the difference between multiple process and multiple thread. In multiple process, each process will have a separate code, each process will have a separate data, each process will have separate set of files opened, each process will have a space for storing its register contents, each process will have a separate space for storing its stack, as we have seen in the process control block, all these details. But when it comes to multi-threaded process, then there is only one set of code, there is only one set of data, there is only one set of memory allocated for the files, details and all that. But each thread has its own register contents to be stored on the memory. Each thread has its own stack. So that's the difference. So when we are trying to work on the same process in multiple ways, then instead of copying the same code again and again multiple times on the main memory, we can keep one copy of the code and allow many users to use it through the threads. So user 1 may use thread 1, user 2 may use thread 2, user 3 may use thread 3 for the same process. That means when we are working on this, that is the same code will be used, same data will be used. So this part is common for all the threads, whereas each thread has these components differently. So that is what a thread is. More details about process, threads and all in the coming sessions. So as of now, that's a introductory session for what a thread is and how it is different from a process, or a process consists of multiple threads and all that. So that's it for now. Thank you.